Hey everybody, welcome back to the Print3D channel. I know we've been doing a lot of product and printer reviews lately and we haven't been doing any fun projects, but that changes today. I've got something really cool to share with everybody. This is RoboKitty, a 3D printable toy, and I'm going to show you step by step on how we put ours together, so stick around. Hey everybody, welcome back, and thank you for joining me here on the Print3D channel. Like I was saying in the introduction, we've been doing a lot of product and printer reviews lately, and we haven't been doing a whole lot of fun projects, and I want to kind of change that for now. We do have some printer reviews coming in the pipeline, but I want to shift things around and do some more fun projects in between the printer reviews and the product reviews, so you guys can see some of the benefits and how these 3D printers actually work. So for today, we have RoboKitty, a 3D printable toy. Now this was a lot of fun to print, and it took a little while to print, and we used quite a few different colors of filament, but there is one thing that isn't 3D printed in the whole model, and that's some springs to launch the missiles and the cannons that are hidden away in his back. But we'll talk about that later. The first thing I want to talk about is the model itself. RoboKitty was designed by James Trachtenberg from Dragon Mountain Design, and his files are posted over on my mini factory with the instructions posted over on his website. And I'll put that link down in the description so you can check everything out. But this was such a fun model to print, and there's some other things that go with it, which are the cannons that are hidden away in his back. And it's part of a whole series called the Cheekymandos, I think it's called, or Cheekymandos. And it's a cool set of toys that you can 3D print for your kid, or for yourself, in this case this is for me, that are really fun to print and assemble, and they take a little bit of effort to put together, because mine did take a little bit of extra post-production work, a little bit of extra sanding, because all the tolerances are really tight. I probably should have test printed a few things. But overall, the model was so much fun to print, and it was so much fun to assemble, and I'm going to take you step by step on how we printed ours and then assembled it, and of course, the finished product. For RoboKitty, we used 5 different colors of filament, and one of them was a flexible material. So the bulk of the parts were printed in AMZ filament. We used AMZ's red for the 2 little eyes, and that was a single part print. We used AMZ's black for most of the parts, and those are the body parts within. We used AMZ's bronze, which we used for the cannons and the parts for the cannon. And then, of course, we used AMZ's yellow for the body part shells and the head. Then we used Matterhackers ProSeries or ProFlex Series TPE. Now, this is some really cool filament. I've used this on some tire prints for my OpenRC F1 car, so I knew it would be perfect for the couplers, and you're going to need 9 of those, so you're going to need be able to print out quite a few of these. Plus, for the little darts that go in the cannon, there's some little rubber tips to protect, obviously, the little kids. And you're going to need to print out 2 of those, or as many of those as you're going to need for as many darts as you're going to want to print. And I would suggest printing out quite a few darts because I'm sure they're going to get lost. And then, of course, you're going to need some springs, and that's the challenge that I came up with. I was hoping to source those locally, but unfortunately, I was unable to find the exact spring size I need at my local hardware store. You can order them from McMaster, and the link will be down in the description. It's also in the instructions. So you can get the proper springs that go for the cannons, and I haven't showed you the cannons yet. So all the files are posted at my mini factory, like I said previously, and that link is down in the description. And once we had everything downloaded, we sent everything to Simplify 3D before we printed everything on the gMax 1.5 XT Plus, even the flexible material on the sanded acrylic bed. So real quick, we'll head over to Simplify 3D and I'll show you my settings for all the prints, including the flexible material. And then we'll go over my assembly video before we return back here to the workbench, and we'll talk a little bit more about RoboKitty, and I'll show you where those cannons are hidden. Okay, so here we are in Simplify 3D, and this is an example of one of the build plates I've set up. I've actually got an example of multiple processes here because I'm going to use some support material on this particular part, and I'm not going to use any support material on some of the other ones. So let's go over my settings now. These will be printed in black, so let's check out my settings for these particular models. We are using 25% infill. We're doing 0.24 millimeter layer heights with 5 top layers, 3 bottom layers, and 3 perimeters. We'll also have our seam at a specific location. Now this is where you're going to want to make sure, depending on the parts you're printing, where your seam lands, because if it's a part that fits together with another part, you're going to want to make sure that that seam lands in a good location. We also ran a skirt at 8 millimeters from the object at 5 outlines just to make sure our extruder was primed and ready. And again, we did use 25% infill. I like to use honeycomb because honestly, honeycomb adds randomly an extra wall, a perimeter wall, when it goes near the wall for the honeycomb style infill, fast honeycomb in particular. So you get a bonus perimeter wall in 90% of the models infill, which is awesome. We didn't generate any support material for some of the parts, but we did for one part, and I can show you my settings for that. For temperature, this is AMZ's PLA. I like to print it at 215 degrees across the board. For cooling, I have a multi-stage cooling setup in every print on my gMax 1.5 XT Plus for a gradual step up because it is a very powerful fan. And of course, I printed this out at 40 millimeters per second, and you can see my modifiers here for different parts of the printing aspect. And I did allow the single extrusion fill under the thin wall behavior. So that was the settings for those particular parts here that are highlighted. For this particular part, we actually used support material. Whoops, that's the wrong profile. We want to use process 2. And we use support material, and you can see my settings for that. So that's the settings for basically for some of the black parts that we printed. And these are structure parts, so I wanted them to be strong. That's why I used 25% infill. So if I go to my recent items here, recent factory files, and I open up one of my color prints, and this is for the covers on the leg, and I only have a single profile here, and we're not doing any support material, and I can show you my settings for that. Here we only use 20% infill. And again, 0.24 millimeter layer height, 5 top, 3 bottom, 3 perimeters, and I have a specific location. As far as additions go, those are basically the same, but here I did run a brim instead of a skirt just to make sure, because there is a little bit of bridging going on, and these parts have a small footprint. Again, 25% infill with fast honeycomb, which gives you an extra bonus perimeter on the interior in about 90% of the locations where an infill's printing with this particular method. No support material, temperature 215 because this is AMZ, and the speed is at 45 millimeters per second for this print, and you can see the modifiers here. And of course, my advanced settings, I like this allow single extrusion fill. I use it a lot on my thin wall behavior. Now, some of the flexible material prints, I can show you that. Here's the sockets, and I printed these 4 up at a time. I actually did one test print, and I posted that out on social media because I was pretty happy with my first print going directly on the sanded acrylic of the gMax 1.5 XT Plus. So I knew I was safe to print out 4 of these. So let's take a look at my settings in Simplify 3D for my flexible filament prints. Now these ran at 20% infill. We did do a 0.28 millimeter layer height with 4 top layers, 3 bottom layers, and only 2 perimeters. And you can see my first layer height is normally 110 on both of these settings, but for flexible material, I wanted a fatter base layer. So I did 120 by 115, and my first layer speed, this is something I've learned with flexible material. You want to stay away from using too many speed modifiers in any part of your settings, because the more times you change speeds, the more times you're going to have a chance for a jam or some kind of issue with flexible material. So normally I would run this on any flex print at 100% on my first layer speed, but because I was printing 4 of them, I dropped it back down to 80. Now I did run a skirt 4 millimeters from the objects at 4 outlines just to prime the extruder. Again, 20% infill, but I do, again, with that fast honeycomb, you're going to get a bonus infill or a bonus infill layer, or bonus infill perimeter using fast honeycomb, so that's a nice bonus. No support, obviously. Temperature, we're running at 238 degrees. This is Matterhackers ProSeries flexible material, and 238 seemed to work really good with my extruder. Now cooling. Cooling's important with flexible material. You don't want a lot of cooling. You want the plastic to cool off on a natural state. So I only have it up at 25%, and that actually might be too much for my gMax 1.5 XT Plus. Under speed, we're down to 15 millimeters per second, and you can see here that I've adjusted my speed modifiers, which are normally set at 75% across the board, to 100% on the outline, 90% on the infill. So under advanced, we do allow that single extrusion fill. Now this is a give or take setting when you're printing with flexible material, but since these are small and they're in a kind of a clamp style, I wanted to make sure that they got as much plastic down as possible, or much flexible plastic down, so they would stay flexible and yet a little bit firm. So those are my settings, and you know what, let's go ahead and prepare to print on this so you can see. It took 1 hour and 43 minutes for these 4 little parts to print, which would probably print in 20 minutes in regular PLA. So those are some basic settings for some of the parts that I did for our RoboKitty. And now we're going to run a little bit of time-lapse footage, and then we'll get to the assembly of our RoboKitty. And once you have all your parts printed out, it's probably going to be a good idea to get everything organized and do all your part cleanup, which includes some of the sanding, removing any of the seams, and any kind of blobs and globs. And of course, test fit all your parts before you start your assembly. Now there are 54 parts in total, and we printed most of the main parts in black. We did have our eyes that are for our little RoboKitty, and we did print those in red. And of course, the parts for the body parts and some of the leg covers were printed in yellow. And there is one part you're going to need support, and that's going to be the skull or the face. Everything else we managed to print without any support material. Now the parts for the cannons, we printed those in bronze. And again, you're going to want to do as much cleanup and test fitting before you start your assembly. The last parts we printed out was our flexible parts in TPE or TPU, which is a flexible material. And you'll need 9 of those parts for the joints. Now the first thing we're going to assemble is we're going to assemble our little cannons. Now if I had the springs, they would go into the sleeves first, but for now we're just going to assemble them so they're set up inside our RoboKitty. First thing you'll need to do is drop in the trigger and then slide in the barrel. Once you have everything in place, the trigger should move easily back and forth. And then you want to make sure that you slide the mount on the proper direction, of course. These are the mounts that are going to go inside the RoboKitty. So once you have one done, you just do the same thing for the second one. Drop in your trigger piece, make sure it's orientated in the correct position, of course, and then slide the barrel in. And the barrel has 2 flat areas that'll make it easy to slide in and orientate for that. And then of course, attach it to the model or the part that's going to go inside RoboKitty. And this is the part that mounts into the rubber piece within inside the body of RoboKitty, so you can move your guns in or your cannons in and out. Now for each of the little missiles, there's a little rubber piece that you're going to need to print, of course, or a TPE or TPU flexible material, and those just snap onto the missiles. And again, I would suggest printing out a whole bunch of these because I'm sure you're going to lose them, because it seems like the spring that's used for the cannons is a very powerful spring. Now again, we just slid ours into position so they're there until the springs arrive, and then we'll load up our cannons properly. The next thing we're going to assemble is we're going to put the arms together and assemble those to the body part. Now there's 2 little pins, and they did require quite a bit of sanding on my particular prints, because they need to snap through and be flush on the arm, because they're going to connect to the yellow body part or whichever color you print it in. So go ahead and snap in the 2 pins that you're going to need for the arms, and make sure you follow the directions, and that link will be down in the description on the positioning of the arms. So you want to pay attention to how you put these on, because once you have them on, you kind of don't want to keep taking them on and off, because they will wear out the pins themselves, because remember, this is just 3D printed plastic. So refer to the instructions, again, that link is down in the description, and snap these onto the body part. And they should freely move, and if they're a little bit too loose, you can always reprint the pins and use them as a little bit tighter fit. Ours were doing pretty good, so I felt these were ready to start moving forward with the rest of the build. Next, we're going to start assembling the inner parts of the model, which is going to include a lot of the flexible material, which is flexible material joints that are going to go into these pre-printed slots, and everything just slides together. Those did not require any cleanup at all. Once you have those 2 parts in, we're going to snap this into the base. Now it needs to slide in a certain direction, and there are little slots for each of the little TPU connector pieces. And once you get it all the way in, it should snap together very tightly. So you might require a little bit of effort to get it in. Now I didn't want to do too much cleanup on here. I wanted everything to have a nice tight fit for this particular part of our RoboKitty. And you can see they snap into place. Next, we're going to snap in our cannons, and those just snap into the rubber or TPU, TPE rubber connectors that we just mounted in, and they'll fold back inside RoboKitty so they can be tucked away. So for now, we'll just tuck them away until we're ready to put them in the proper position. There's more parts that we need to add into the interior. So next part we're going to build is basically the shoulder apparatus, and we're going to need some of these pins, and I believe there were 6 of them that printed total with the package, and everything is in the build plates as you saw in Simplify 3D. And I did do a lot of extra sanding on these because I did have a little bit of over extrusion, and of course the seam did cause some issues, so you might have to do a little bit of extra sanding on all these little ball joint pins that are going to go in multiple areas around the RoboKitty. Once you have those pins locked into position, and make sure they're in there nice and tight, they should snap fully in. The next thing we're going to want to do is we're going to want to add in what they call the spine piece or the backbone piece. And there is a slot for that. And again, you may have to do a little bit of cleanup on your parts, but that should seat perfectly flat and all the way in. And we've got to make sure that goes all the way in, because if they don't, all these parts don't fit in properly, when you go to fully assemble RoboKitty, all the seams won't align and you'll have problems. So we'll bend out our little cannons here. We'll just fold those out. And there's a wide slot at the top there. And you can see there's a slot that needs to face out in a certain direction. So again, make sure you pay proper attention to the instructions online, and that link again is down in the description. Be careful to snap this into place, because this is where you're going to mount the legs. And again, you may have to use a little bit of force depending on how much cleanup, and you want it to be a tight fit. You don't want it to be a loose fit. And it does suggest that if you need to use a little super glue, you can. Now we're going to put in this X-shaped shaft down to the other connector that actually connects to the top piece, and these are all keyed. So pay attention to how these all fit together, and you can see that the X connector or X shaft slides down into the bottom, and that top connector goes into the top there. And again, it may take a little bit of effort to snap these parts together, but depending on the type of plastic you use, you should be able to put a little force on it. And as you can see, I put a lot of force on this to snap everything together. Now we'll insert our top pin, and this is going to be for the neck, I believe. Now we're going to put on the belly cover, and this is the cover that's going to cover our cannons. So what we're going to want to do is we're going to want to make sure that we fold in the cannons before we assemble it, because you're going to want to make sure that everything fits in tightly. So as you can see, these all fit and they tuck in underneath the little top shoulder part. And then there's two pins on either side of the black piece there, and they connect to the small holes that have been 3D printed on the back part that opens up. And you just have to align the pins and snap them into place. Once it's attached, it should be able to open and close freely. Next, we're going to assemble the leg pieces that are going to go on for our RoboKitty, and we're going to use some more of those flexible hinge prints for the connectors for these, because these are also going to connect to ball joints in two different spots on the legs. So go ahead and slide on each of the little TPU or TPE, depending on the material that you use, onto each end of the interior parts. These are the basic structure that goes inside the other parts. And again, I did do a lot of sanding on these just to make sure everything snapped together perfectly. I didn't do any cleanup really on the TPU or TPE prints at all, because those are somewhat flexible and they have a little bit of give. Now what we're going to do is we're going to slide in the first set going into the top part. Again, the yellow printed parts have grooves in them and they all align perfectly, and when you snap them into place, you'll hear a distinctive snap as each of the parts connect. Then we'll put the bottom black sleeves over the tops, over the interior parts of the legs. And again, everything snaps together nicely. You may have to do a little bit of cleanup on the sleeves, but it's worth the effort. Again, if you do need some super glue, feel free to use it. Just make sure you don't get any super glue on the flexible printed parts. Now we're going to attach our big feet, and these are 3D printed ball joints that are on the bottom here, and they didn't require any support. And of course, they're going to snap nicely into the flexible printed parts. And this gives you a nice full range of movement, but it gives you a limited area to the left and right so it won't fall over. And it gives it a nice degree of movement there, so it'll have a really good balance. You want to make sure you snap those in really tight. Again, snapping in the interior parts with the TPU parts inside the sleeves will ensure that you get a good connection to all the joints that are on the RoboKitty. Now we're going to attach the legs to the body. Again, refer to the instructions for orientation, because you don't want to put the legs on backwards or put the wrong leg on the wrong side. And as you can see, everything snaps together really nice, and it gives a full range of movement because it is a very tight fit around the TPU and the 3D printed ball joint part. Now it's time to assemble the tail parts, and it's basically the same thing twice. You're going to assemble each of these parts exactly the same, and we did sand a couple of the ball joint connectors down just to make sure they fit tightly. You'll attach your flexible printed parts to the ends of each of these, and they slide together very easily. And then you'll take the printed sleeve parts, and they slide in through the top. Now there is a little groove for each of the ball joint pins to slide into, and it should slide all the way down and snap into place. And just repeat the process for the other part of the tail. And you can see there's that little slot. Now you just snap the two pieces together to create the entire tail. And it should have a nice firm fit so you can get a nice full range of motion from the tail and it won't fall down. Now just connect it to the rear of the RoboKitty and the tail is complete. Now we're going to work on the details for the head part, and that's adding the eyes. And we printed ours in some red, and we did do a little bit of sanding because this does have to slide within the head part. And you're also going to use your last flexible part because this is where your head joint or your neck joint is going to be. Now take the skull, and you're going to need the jaw piece as well. And you can see it has a few slots near the top, and that's where the eyes slide in. And then just below that is where the connector piece and your flexible print go in. And you'll just have to work this in slowly. It may take a little bit of effort, and you may want to do a little bit of cleanup on the slots on the head piece, just in case your seam landed there or you have a little bit of over extrusion. But eventually it'll snap into place, and you'll know it's all the way in when you can't feel a gap in the inside, but you can see the eyes are starting to poke out through the front. The last part is to connect the jaw piece, and that just snaps into place. This is a 3-position jaw piece, so there are some grooves and some notches, so make sure that you align those pins properly and snap it into place the way it's designed, so you can get those multiple positions on the jaw piece. Lastly, we'll add our ball connector, which goes on the very front of the RoboKitty, and this snaps into place. And again, you may have to do a little bit of cleanup. You want this to seat firmly in, and you can kind of manhandle the print as long as you've used a lot of perimeters and infill and made this kind of strong, which we did. And then of course, just attach the head, and your RoboKitty is complete. Stashed away in the back of the RoboKitty is where our cannons are hidden. You can just fold these out and then fold down the compartment door, and now your RoboKitty is fully armed for battle. So once we had everything printed and assembled, it was time to have some fun with RoboKitty. Now, a full disclosure, I did have to sand quite a few of the parts. There was some stringing involved. Some of the seams landed right in the openings of where I needed to slide parts in, so those had to be cleaned off. So I felt that it was easier just to sand a lot of the parts previously to assembly, just to make sure the assembly process went easily and it didn't have any problems. So full disclosure, I did clean up some of the parts. It's a little bit of over extrusion and the seam location, but not a big deal. You can fix that in your print settings so you can avoid doing that. And you definitely want to do that because there are some parts, there are quite a few parts in fact that slide together. Obviously these parts here slide together to make the legs, and there's some parts in the internals that slide together. So you want to make sure you clean up your parts really good and make sure your seam location isn't inside any of the models. Sure, it's going to be on the outside, and you can see it in some of the pictures of mine. There is some seam locations on the outside, but this is a toy and it's a lot more fun, and it's a little less something to be critical on because it's probably going to get beat up by the kids. So anyway, the print itself turned out awesome. I'm super happy with the results. The gMax did a stellar job. We printed out quite a few different build plates, including flexible material, which was a little bit challenging to print. If you've never printed with it before, you definitely have to take your time with that. But all the parts printed out really, really nice, like I said, and the assembly went along pretty easily once I had all the parts cleaned up. And of course, everything moves. It's got lots of different flexible positions. The mouth opens up into 3 different positions. You can have it just open a little bit, open a lot, or closed all the way. And with those flexible material joints that are in a lot of different locations in here, that gives you the ability to move the different parts of the body around, including the legs and the feet themselves. Oh, the foot just came off. I'm going to actually take this off, and take a little effort to pop it off. I'm going to set RoboKitty down. Sorry, RoboKitty. So you can see that there are flexible joints within each. And you do have to make sure that these things have very clean interiors to the parts. Again, make sure you clean up your parts really well, because you want everything to slide together nicely, and then it snaps into place in almost every connector, just to make sure that the rubber pieces that are exposed grip perfectly on all the parts. So you want to make sure that everything is snapped together nicely. And then once you have it all snapped together and all assembled, it's a really fun toy to play with. Now I'm going to put the leg together and put it back on RoboKitty because he looks really hurt laying there. So let me put this back together. Make sure I'm doing this right, of course. And make sure you check your part orientation too when you're printing and you're assembling, because you don't want to put on any legs backward or anything. But all the parts just snap together like that because of those rubber joints. And he's fully posable. And of course, like I've been saying earlier, he does have some hidden cannons in his back. Now, let me pose this a couple different ways. If you lift open this back panel here, inside here, now the little cannons, they actually fold out, and they come out pretty easy. I was just struggling because we're on camera here. But they fold out nicely. And these don't have the springs in them right now because I have to order those from McMaster's, because like I said, I had some difficulty locating them locally. But then you just close the back, and now you have a fully armed RoboKitty. And there's little trigger switches on here, and I did print out a couple extra missiles for it. So like I said, overall, this was a really fun project to print. I think it's an awesome toy for kids. You can scale this up to any size, pretty much any size. This is at 100%. I do have a gMax printer, and I probably could have gMax sized this, but that episode would have taken at least a month to put out because these parts would have been huge. And of course, printing the flexible material joints for a gMax sized version of this, that probably would have taken a month alone just to print that. But I'm really happy with the way this looks. It's really cool. It's fully posable. Even his little arms move. I know he's really not a kitty. He's just named after the kitty of the designer, who has, or named after the T-Rex toy that the designer's daughter calls Kitty. So this is RoboKitty. And there's even an insignia RK001. And on the other side, you can see the Dragon Mountain logo on here. So overall, this is a fun project to print. If you've got a lot of time and some materials, definitely going to need some flexible materials, and make sure your printer's dialed in really, really good for all the tolerances. It takes a little bit of cleanup at the end if you locate, especially if you locate your seams in the interior of your parts. But other than that, once it's all assembled, you have this really cool RoboKitty. Well, I hope you guys found this episode interesting and informative. And if you're looking for ways to support the channel, check out that Patreon link down in the description, along with all the other affiliate links that are down there. Those really help support the channel. And of course, don't forget to subscribe to the channel, comment, like, and share those videos, and I'll talk to you guys soon.